Why bother learning Objective-C? Nobody does Command-Shift and new Xcode project and selects Objective-C. Objective-C is dead, right? Well, Objective-C may be old, but it is far from dead and remains a useful skill to learn for iOS developers for several big reasons. It still remains a valuable skill to learn. And if you do work with one of these legacy code bases, or you work with a legacy framework, or you want to modernize an Objective-C code base to Swift, you still need knowledge of Objective-C. Hey everyone, my name is Zach Brass. Welcome to the session right before lunch, so thanks for bearing with me. This is Objective-C, Remember Me. Here's my obligatory Who Am I slide. I'm Zach. I'm an iOS developer living in New York City, USA. I've been doing iOS professionally for about 12 years at all different types of companies. In my spare time, I have two different hobbies. I compete in pun competitions. There I am at Punderdome in New York City. I'm also a swing dancer and blues dancer, and I've been teaching dance for a little over a decade. I also have a day job who I'm not here representing today, so I'm putting up this disclaimer. So, I want to start with a little history lesson here. We're going to travel back in time to like a vague period of time known as the 80s. We were in the tail end of the Cold War, web browsers hadn't come out yet, and I was barely an idea. The language we now know as Objective-C was released in 1983 by a company called Stepstone, which means it's technically older than C++ by about 2 years. It was initially called Object-Oriented Precompiler, which is kind of a mouthful, and when abbreviated kind of sounds like oopsie, so it was renamed Objective-C. And Objective-C introduced the then brand new object-oriented functionality to C while still being a proper superset of C, unlike C++. But the pivotal thing that kicked off the chain of events of why we're even talking about it today is when Objective-C was adopted by a newly formed company called Next Computer Inc. in the mid to late 80s. So its OS called Next Step was built using Objective-C and was a pivotal part of computing history, not just our history. It was the first OS to run the first web browser. It was the first OS to run Doom. And more relevantly to this talk, when Next was bought by Apple in the 90s and Steve Jobs was reinstated as CEO in the mid-90s, Next Step laid the foundation for another operating system, Mac OS X. And Objective-C came with it in the form of the Cocoa frameworks. So fast forward to 2008, the iPhone had been out for about a year. I looked like this. And Apple announced what was then known as the iPhone SDK. And with Apple touting that the iPhone's OS was basically Mac OS X, the Cocoa Touch frameworks were based on Cocoa from OS X, and the language of the SDK was Objective-C. And as the iPhone rose in popularity, so did Objective-C. So fast forward to 2014. I looked like this. Here I am at WWDC 2014. About 24 hours after this picture was taken at the same WWDC, Apple asked us what would happen if we had Objective-C without all of the baggage of C, and thus Swift was born. So the year is 2024. I look like this. iOS has been around long enough that it can almost vote in most countries, and the language to write code for Apple platforms is Swift. There are iOS developers who only know how to code in Swift, which is kind of the purpose of this talk. Swift in 2024 is a super modern language that's constantly evolving and being maintained not just by Apple, but by the developer community as well. So like, why bother? Why bother learning Objective-C? Nobody does Command-Shift and new Xcode project and selects Objective-C. Objective-C is dead, right? Well, Objective-C may be old, but it is far from dead and remains a useful skill to learn for iOS developers for several big reasons. The first reason is that Objective-C remains the better choice for working with C or C++ code. So C++ interoperability in Swift was only announced this past dub, and with its partial compatibility, Swift has a long way to go before it's to the level of the interoperability that Objective-C has with C++. Another reason is the massive wealth of knowledge of Apple platforms that exists on sites like GitHub and Stack Overflow that's written entirely or in part in Objective-C. And so even if you're not writing Objective-C, knowing how to read it makes you that much more able to help yourself. But the main reason is that for better or for worse, there are actively maintained Objective-C codebases that you might actually work in today. Like, the thing is, people didn't stop writing Objective-C in 2014 when Swift was announced. Like, given how buggy the first few versions were, developers were still debating whether to even start adopting Swift until years after, and some code bases didn't even bother because they were past the point of no return. And even in 2024, if you get a job at a big tech company, like a FANG company, chances are you'll encounter, and in many cases be writing, Objective-C. Now, I can't speak to my current job because I'm not here representing them, but at every single one of my previous employers, I've written a non-trivial amount of Objective-C. Look, the point of this talk is not to say you should Command-Shift-N new Xcode project and select Objective-C, but it still remains a valuable skill to learn. And if you do work with one of these legacy code bases, or you work with a legacy framework, or you want to modernize an Objective-C code base to Swift, you still need knowledge of Objective-C. So perhaps a better name for this talk would be an intro to Objective-C if you must write Objective-C, or perhaps Objective-C for reluctant Swift developers. And we're going to cram as much Objective-C as we can into this talk to get you off the ground. So that means for the experienced Objective-C devs in this room that decided to come, I'm not going to talk about dynamic dispatch, and I'm definitely not going to talk about method swizzling. We're going to start with something small and not super scary. Just kidding, it's method syntax time, baby! Pew, 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 pew. So, this is the bracket syntax that every non-Objective-C developer, got it the third time, non-Objective-C developer gets real scared of. We have our caller, SomeObject, and our method, doSomething. Note that since this is a C-based language, we end lines with semicolons. And don't worry, I made sure to put a little box for the Swift equivalent, not just to show parallels, but also to subtly hint that Objective-C and Swift share most of the same APIs in the SDK. So when coding apps in Objective-C, you're not starting from zero if you're already a Swift developer. So if you really want your dot syntax in Objective-C, you can still use it on properties, and that's perfectly valid Objective-C syntax. Technically, you can still use dot syntax for methods with no arguments, but mostly for methods, you'll use bracket syntax. So let's add an argument to our method. This is how we call it. See? Not so bad. You all can do this. Now let's add another arg. Here's where it gets a little tricky, but we're used to interspersing method signature and arguments in Swift. We know that our method is called doSomething with arg, other arg, and that our arguments are arg1 and arg2. So that's method calling. How do method signatures look? All right, here's where it gets a little different. So first thing to note, this tiny note, that dash at the beginning of the method signature in Objective-C, that denotes an instance method. So if we change it to a plus, that would denote a class method. But we still have our method signature, doSomething with arg, other arg, our argument names, arg1 name and arg2 name, our argument types, arg1 type and arg2 type, and our return type called return type. So what are these actual types? Let's talk about what types you might actually use. So in Swift, we have our basic string, array, and dictionary. In Objective-C, they're NSString, NSArray, and NSDictionary. What's with the NS part? Turns out Objective-C doesn't have namespacing, so as a workaround, type names in frameworks, both from Apple and third-party developers, are often prefixed with 2- or 3-letter abbreviations to distinguish themselves. The NS stands for not namespace, but for next step, and it's for the Foundation framework, since it evolved from next step and just kept the prefix. Now, you may recognize this pattern from elsewhere in the SDK with UI Table View Controller in UIKit, CG Size in Core Graphics, and MF Message Composed View Controller text message availability did change from the Message UI framework. So these are the equivalents of string, array, and dictionary in Objective-C, but with one little asterisk, which is literally an asterisk. In Swift, strings, arrays, and dictionaries are structs, which are value types, but in Objective-C, they're classes, which are reference types. So in declaring them, and whenever we declare a class, we use the asterisk, which comes from C when dealing with pointers. So let's create some objects. So first I'm gonna take a little drink of water. First, we'll start with literals. So this is how you declare an NS string, NS array, and dictionary, NS dictionary literal in Objective-C. 3 things to note here. Number 1, no type inference. When you declare a variable, you have to specify its type. Number 2, we use the @ symbol for Objective-C literals. You're gonna see the @ symbol a lot. This distinguishes them from their C counterparts. And 3, the dictionary literal uses curly braces instead of square braces like in Swift. So if we don't want to create our dictionary using a literal, we can use an init method. You all know init methods from Swift, but in Objective-C, to call an init method, you have to allocate the memory first. So you call alloc on the class, and then you call init on that. So we can also create objects using factory-style methods like this one. So these are class methods that are from the days before Objective-C had automatic reference counting, where alloc init would return a retained object, and the factory-style method would return an auto-release object. Now, unless you're getting really, really nitpicky with memory management, you don't have to worry about the differences between these two. Also, you might run into new to create an object. Calling new is just syntactic sugar for calling alloc init with no arguments. Now, there's one more fun thing about reference types, and that's operations on them. So since the actual type resolved to some address in memory, you cannot use the plus operator with strings, or collections in general for that matter. If you want to make this string that will definitely get me uninvited from Swift Heroes next year, you have to use my favorite method for explaining how verbose Objective-C is: string by appending string. Amazing. Also, another thing to note, that since this is a reference type, comparing instances using double equals will only return true if they're pointing to the same place in memory. If you want to compare values of objects, you have to use the isEqual method. Sometimes there may be class-specific methods in addition, like isEqual to string, but isEqual works for any objects. So now let's talk about mutability. In Swift, we're forced to use var and let to determine mutability, but in Objective-C, it's a little bit different. Now, there is an equivalent to let in Objective-C, and it's const, but I'm actually gonna skip over it for this talk because it's not nearly as widely used as let in Swift, and if you Google it later, you'll see why it's a massive can of worms that is not fit for an intro talk. So, in Objective-C, objects are, by default, mutable, but there are some specific objects whose contents are not. So it's mostly just strings and collections in Objective-C that are immutable, but they do have mutable subclasses. So here's how it susses out in practice. If I have an NS array, I cannot modify the contents of that array. However, I can point the toppings array to a different place in memory to redefine the variable, and this is valid Objective-C. But if I want to modify the contents of an array without redefining it, I have to use NS mutable array, and then I can use the add object method of NS mutable array, or use subscripting syntax to replace an object. So we've talked about strings, arrays, and dictionaries as classes. What about numbers? A little bit more complicated. Numbers, and I'm lumping Booleans in there too, are mostly value types. 9 times out of 10 in Objective-C, if you're dealing with mathy stuff, you're going to be using C value types. A couple things to note here. It's more common to use CG float and NS integer over float, double, long, and int. The CG float and NS integer types were created to allow the max size to be different on 32 versus 64-bit systems. Swift, I believe, already does this. Also, bools in Objective-C accept both yes, no, and true, false, all caps. Now, there is also NS number, which is unique in that it's an Objective-C object type, if you have to use an object type. But overall, there's a much bigger difference in Objective-C between value types and reference types than there is in Swift. In Objective-C, value types are stuff, but they can't do stuff. So in Swift, you can call methods on value types. In Objective-C, you have to use C-style functions. And in C, functions, unfortunately, don't have named arguments. That being said, operators like addition and multiplication still work on value type numbers, which is great. Okay, but what about things like structs and enums? Enums, it's pretty simple. Enums have an underlying type of an integer, or anything that has an integer value like NSU, integer, int, or even bool. And if you want, you can still define the underlying values. Anything you can do with integers, you can also do with enum values. Unfortunately, this means no associated values and no methods on enums in Objective-C. Also, unlike Objective-C, or unlike Swift, the naming convention is to always prepend the enum case with the enum name. So it's not just sunny, cloudy, raining. It's fully weather condition sunny, weather condition cloudy, weather condition rainy. Structs in Objective-C are just C structs, which means, again, no methods, no protocols, just their named elements. So structs themselves are value types, but their elements can be reference types. It's rare that you'll actually create a struct when writing Objective-C, but you'll encounter them plenty in the SDK, especially in core graphics. So things like CG point, CG rect, CG size, etc., are all structs in Objective-C. And they come with these C-style functions to create them, since they aren't Objective-C objects. But you can still use dot syntax to modify their attributes. So there's one more type left that I want to introduce, and it's blocks. It's not exactly right to say that blocks in Objective-C are the same as closures in Swift, but more like blocks are the functional equivalent to closures in Swift. They are self-contained functions that you can pass around in your code. If you worked with other languages, they're also known as lambda functions. So we're just going to go ahead and define an easy block called log hello that does just that. It logs hello. It doesn't return anything, which is that first void, and it doesn't take any arguments, which is that second void. That caret is the indicator that we're using a block. If we want to call the block, simple, we use a C-style function. All right, here's another block that takes 2 NS string arguments and returns their concatenated value using my favorite string by appending string method. For the sake of font size, we'll declare the concatenate block before defining it. Here's an example of a thing that you're probably familiar with. Here's an example of a completion block used as a method argument. This pattern is used in Swift as well. Now, just like Swift closures, if we're capturing self, we want to avoid a circular retain cycle, so we have to make sure we weakify self, and that's how you do it. Now, if you're getting a little overwhelmed and you're like, oh my God, this fucking block syntax, I can't remember where everything goes, you're not alone. If you need a guide, you can check out fuckingblocksyntax.com. This is not my website. This is not my website. You can clap for it anyway. Not my website, but it is an often referenced website when you inevitably forget the fucking block syntax. Now, there is one thing we sort of glossed over, and it's nullability. In Swift, you have to be explicit about whether things are nullable or non-null, right? Does Objective-C require explicit nullability? No. But also false. 0. 0.0. Nil? Thing is, until otherwise defined, any variable in Objective-C starts out as one of these. And unlike languages like JavaScript, these are all equivalent, and you can double equals them. And they'll return true, right? Because they're all equivalent. JavaScript, I'm looking at you. Now, there is something special about nil, though. In Objective-C, you can call methods on nil. And here's an example. If we declare a string variable but don't define it, it will just default to nil. But we can still call methods on it. It'll just do nothing and return nil for any method that has a return value. Here's another example of this. In this case, we'll enter the if block if the array is non-null and the count is 0, since 0 is equivalent to false. But also, we'll enter the block if the array is nil, just entirely, since the method will resolve to nil, since nil is equivalent to false. This is actually one of the ways that you can be more concise in Objective-C. And it should come as no surprise in all of this that Objective-C does not have guard statements. But, on the other hand, at least your app will never have a force unwrap crash in Objective-C code. And if you want to be explicit and differentiate, you can always make a separate check to see if an object is nil. So now that we've talked a lot about Objective-C foundations, pun intended, let's talk about how a class is made. So class definitions are split up into two files, and I will split this section by taking a water break. Two files, header file and implementation file. Why is implementation.m? Some people say messages, some people say methods, no one's quite sure. The reason it's split into two files is for access control. In Swift, we define things like public and private on a per symbol basis. Public func, private struct, when defining the actual symbols. In Objective-C, it's done on a per file basis, using things defined in header files and importing them in other files. So what might we find in each of the files? We're going to make a view controller that's super simple form with a text field and a submit button. So let's start in our header file. First thing we have in our header file is our imports. We import not only our frameworks, which we import using angle brackets, but also the individual files within our project that we want to use using quotes. In this case, we have another file that defines a delegate for our sample view controller, and we'll import it here. Note that there's also another way to import frameworks in Objective-C using @import. For some reason, this type of import requires a semicolon, while the others don't. Now, given that headers can import other headers, we want to ensure that two header files don't import each other. So if one header needs to know about a class or a protocol from another header, you can use @class or @protocol below your imports to basically say, trust me, the symbol exists, and then do the actual import in somewhere else, like in an implementation file. Now, our sample view controller doesn't have to do this, but sample view controller delegate.h needs to know about our sample view controller. So that header will contain @class sample view controller. So next thing down is we're going to declare our class to the outside world. So we name our class sample view controller, and it inherits from the superclass UI view controller. And we're going to put everything in our declaration between @interface and @end. If we want to add protocol conformances, you add it in angle brackets after the superclass. And we want to do this since we have a view with a text field and want to conform to the UI text field delegate protocol. Finally, in our header, we are going to declare our methods and our properties. So first, let's add our methods. Here, I've created an init method and an IB action. So we've covered method declarations in text before, but I want to point out a couple things. So number one, we only declare the method signature here. We implement it in our implementation file. Two, instance type. What's that? Instance type is like capital S self in Swift and is generally the return type for init methods. And number 3, there is no distinction or marker for a designated initializer or a convenience initializer in Objective-C. All right, so let's add our properties. Look more at symbols. We've got an IB outlet, that's our UI button, and we've got our delegate, that's of type ID, but conforms to the delegate protocol we imported earlier. So ID is sort of the catch-all type in Objective-C that's sort of like any in Swift. So now let's look at all those things in parentheses. Those are our property attributes. Let's talk about some of these attributes that you might see. So strong and weak you're already familiar with in Swift, but it's worth noting that they should only be used for objects, not value types. Atomic and non-atomic. So atomicity, atomicness, English is my first language. Atomicness has to do with thread safety. Atomic properties use locks to keep themselves thread safe, but they're going to be very, very slow. I think I've only ever seen one atomic property in any code base I've ever used, so use non-atomic unless you're 100% sure you know what you're doing. Copy, pretty obvious. Adding copy to the property will return a copy of the property when you call it. Read-only and read-write, so properties are read-write by default, but you can set them as read-only. Note that internal to the class, you can still modify the underlying variable of that property. Now, if you're feeling extra frisky, you can actually give custom getter and setter names. So for example, if your property is named enabled, you can change the getter to is-enabled. So that's our header file. Let's check out what we put in our implementation file. First thing, more import statements. We import our class's header file in the implementation, and since that header already imported UIKit, we're done with our imports. Next thing, wait, what the heck? Another interface? What's up with that? Turns out this is actually a class extension. I prepared that. And it goes inside of your implementation for declaring any additional properties or methods that you want to expose just to the internals of this implementation file. You can even redeclare properties from your header file. For example, if you want a property to be read-only to the outside world but read-write internally. Note that Objective-C extensions are a little bit different from Swift extensions. Swift extensions cannot declare additional stored properties. Now, if you want something that's similar to Swift extensions, check out the documentation for Objective-C categories. Now that we got our actual implementation, next thing we've got our implementation. So we're going to define all of the methods that we declared earlier, either in the class extension or in the header file. So first thing, we have our init method. Note that in any init method, we always have to call some other init method, whether it's a different init method of this class or one of a superclass. And we want to define any properties' initial values, and so we'll do that in this if-self statement. Next thing, we've got our viewDidLoad method, and even though this is overriding a method of our superclass, we don't need to call override in Objective-C. And then we add our IB action method for a button press and a UI text field delegate method for when the user presses the return key, both of which will tell our delegate that we just submitted our little form. And that's our implementation. Look, we just made a class. Okay, now I'm gonna take a water break. Important to hydrate when you're writing Objective-C. Now let's talk about how to use Objective-C in the same project. So, first thing, how do I set it up? If you have an all Objective-C project or an all Swift project, and you add your first file of the other language, you'll get this convenient little alert to create a bridging header. Click create because doing this manually is an absolute chore. So in addition to creating this additional file, it actually sets up the infrastructure under the hood in your project to share code both ways. But we still have to manually expose our code. So how do we do that? So let's start with exposing Objective-C to Swift. Remember how in Objective-C, access control is done on a per file basis through imports. So this is where our bridging header comes in. Anything that you import in the bridging header gets exposed to the entire module in Swift, and you can call everything now using Swift syntax. Now, when exposing Swift to Objective-C, remember access control in Swift is done on a per symbol basis when defining the actual symbol. So just like we do with access control keywords like public or private, if we want to expose our Swift code to Objective-C, we have to mark our types, our properties, our functions with @obj_c to expose them to Objective-C. IB outlets and IB actions sort of come with this baked in for convenience, but if you want even more convenience, you can define a Swift class with @obj_c members, and it'll expose all methods and properties as @obj_c under the hood. And if there's something you don't want exposed explicitly, you can mark it as @non-obj_c. Now, back in our Objective-C code, we have to actually import it, and to do that, we need to use a different header from the bridging header that is an auto-generated file under the hood called whatever your module is named, .swift. And if you import that file in Objective-C, you'll be able to use everything that's exposed on the Swift side using Objective-C syntax. If you want to view what your Objective-C code looks like to Swift or vice versa, you can use that little corner menu in Xcode, which I learned recently is called the Related Items menu. And from the Related Items menu, you select Generated Interface. For Objective-C files, you'll see your generated Swift header on a per file basis. And for Swift files, you can select that entire auto-generated Objective-C module header. You might want to have to scroll down to the end behind a bunch of like pound defines. Well, hold on a second. There were some slight differences in naming conventions, right? The biggest one, right? Remember that slide on enums? Those are named really, really differently in Objective-C and Swift. So turns out, yeah, no, we're good. If you name your enums like this in Objective-C, the bridging will just automatically chop off the enum name from all your cases in Swift. And in Swift, if you name all your enums with proper Swift conventions, it'll automatically take your cases in Swift and tape the enum name and even fix the lowercase to uppercase, just like magic. Everybody say ooh on 3. 1, 2, 3. Ooh, nice. Also, remember how we have strings, arrays, and dictionary in Swift, but NSString, NSArray, and NSDictionary in Objective-C? Well, for pretty much anything else in Foundation, you'll use the NS prefix in Objective-C for the names and no prefix in Swift. The types will be automatically corrected for you when bridging. Now, if you don't like how your symbol names are bridged by default, don't worry, you can specify a custom name in the other language using NSSwiftName in Objective-C or @obj_c in Swift. Bridging numbers works too. NSNumber is one of the few exceptions in Foundations where the NS isn't chopped off in Swift, but these are normal number types in Swift and normal number types in Objective-C. What about methods? This is our slide from earlier, and again, we're actually good here. This is how a method defined like this would be bridged. This is how it would look in Objective-C and how it would look in Swift, bridged. Under the hood, if you name your function right, Swift will actually look for the word with in your method name and smartly insert the opening parentheses in the right place. Now, if you're obsessive over your Swift naming, which I am, you know that there's actually another naming convention where you leave out the argument type if the method name matches the argument type, right? So Objective-C does not have this naming convention since Objective-C, unfortunately, does not have method overloading. However, if your naming is on point, the change will just happen for you. And again, if there's something that's not exactly right, you can use NSSwiftName in Objective-C and @obj_c in Swift to specify the exact signature that you want. Okay, well, Swift has a bunch of features that Objective-C doesn't have. How do they bridge to Objective-C? Unfortunately, not every feature in Swift bridges to Objective-C. So this means that enums with associated values, tuples, and Swift structs, including Swift UI, do not bridge to Objective-C. Flame effect. On three, everybody say "aw." 1, 2, 3, "aw." All right, glad you're with me. But there are some feature differences that do bridge. First one is nullability. Now, when I said Objective-C doesn't do explicit nullability annotations, that is technically true. But I do want to add some slight nuance to a slide that I made earlier. So to say that these symbols in Objective-C and Swift bridge to each other isn't 100% right. From Swift to Objective-C, this is right, but from Objective-C to Swift, they bridge to force unwrapped optionals. If you want to fix this for your methods and properties, you can add nullability annotations using nullable and non-null, and you'll get rid of those pesky forced unwraps when bridging to Swift. And as a convenience, you can wrap your code in NS assume non-null begin and NS and non-null end, and it'll just assume that everything is non-null, and you'll only have to specify when things are nullable. Now hold on a sec. I've said twice now that Objective-C doesn't do nullability definitions, and it doesn't. In reality, these are just guidelines to basically help Swift bridging, and they are not enforced at all at compile time. Under the hood, you can do whatever you want, which is mostly the case for all Objective-C. You can absolutely set a non-null marked Objective-C property to nil, and the worst thing you'll get is a compile time warning. But if Swift encounters nil when it thinks it shouldn't be, you'll definitely get a crash. Same thing with generics in Objective-C. A normal NS dictionary bridges to a dictionary, which is hashable for the keys and any for the values, but you can specify your key and value types in Objective-C, and it'll bridge to the specific bridge type in Swift. But under the hood, you can just do whatever you want with that Objective-C dictionary, and it's up to you to keep those guidelines and not ignore the compiler warnings. So here's one thing that you might not expect that does bridge to Objective-C: async await. But when you remember that async await, when async await came out, we were all migrating from like trailing closures. And that's the key here. Remember when I said earlier that the functional equivalent of closures is blocks in Objective-C? Well, that's what async await functions bridge to. This is the only part of the talk where I am not going into the syntax of this. Why? There's why. But I did make you a chart to explain the bridging. So if you define a method with async in Swift, you get a similarly named method in Objective-C with an additional argument that's a completion handler in Objective-C. So turns out the completion closure equivalent of that async func in Swift bridges to just same thing in Objective-C. Okay, what about going the other way? We have a completion block, a method with a completion block in Objective-C. Which one am I gonna get? Drum roll, both. Flexibility for all y'all. So definitely, like, for the actual syntax, check the docs, including how adding throws in Swift does still bridge to Objective-C. It just uses NS error and still bridges nicely with completion blocks. Phew, okay. Deep breath, everybody. We covered a lot of Objective-C today. So let's look to the future. The year is 2024, and you all look like, wait a sec. We need to take a picture together. Hold on one sec. All right, so here's the deal. I'm gonna take a video selfie. Y'all are gonna go nuts because I had a 12-hour travel day with like a flight delay 2 days ago, and so you all are gonna go nuts when I say so, all right? So, Swift heroes, Torino, make some noise! Yeah, okay. So I'm just gonna like airdrop this to my laptop. I'm gonna add in, yeah, airdrop worked. We're gonna put this in the presentation. Do. Yeah. Doom. Let's add in, yeah. All right. Let's back up. All right. So the year is 2024. You all look like this. And where you once saw Objective-C as a scary old monster, Now you see it as a furry friend. So everybody, go ahead, switch that documentation over to Objective-C and begin your learning journey and dive into those legacy code bases. You got this. Thanks so much.